Welcome to the video on multiplication and division equations, one-step equations where you use multiplying and dividing. The first thing that we're going to look at today are just some equations. You'll see some like 3x equals 30, and you'll know that kind of by guessing and checking, we'll know that that answer is 10. We'll also see things like x over 6 equals 1. We'll try to see how we can solve those equations today. So the division property of equality basically says that you can divide both sides by any number as long as it's the same number, and that was one valid step, or one step you can actually use to solve an equation. Okay, so I'm not worried too much about the actual property. You won't be tested on that. We're just going to be using it. So our first example here, we're going to solve an equation using division. And remember from before, we've talked about inverse operations. The inverse operation of multiplying is division. Okay. So a little quick side note here. In between -7 and x, there's really a times symbol there. So we are having its multiplication going on right now. We now need to undo multiplication. Our goal is still to isolate the variable. So people will ask, well, do we divide by -7 or do we divide by 42? We need to divide by the -7 because that's what will get rid of the -7 for x. So here we're going to actually divide both sides. And instead of using the division symbol, I use a division bar. This line is dividing. So we're actually going to divide by the number itself, -7. And a lot of people will say, well, why don't we just divide by +7? But remember your rules. -7 divided by -7, negative divided by negative is positive. We want it to be +1. So -7 divided by -7 is +1x. And that is what we want. We want to get just x. And 1x is the same thing as just x. So that property of equality says we have to do it to both sides to keep it in balance. So when we do 42 divided by -7, we get -6. So the answer is x equals -6. And you can check it. To check it, you do -7 times what we thought it was for x, which is -6. We're substituting the -6 in for x, and we want to see if that's equal to 42. And we actually make sure that that is. So that's our first equation. Number 2, we have 5 times x equals 45. This one's a bit easier because we don't have a negative. So we want to get x by itself here. We've got to get rid of that 5. Opposite of multiplying by 5 is dividing by 5. And when we do that, 5 divided by 5 is 1, so we can kind of cancel it out there. Or you can even put the 1 there if you want to. But when we divide that, we get x equals 9. To check it, we'll do 5 times 9 and see if that's equal to 45. If you do this little check on your own, you will be guaranteed that the question is right, as long as the check works out. Alright, just a few more to try here. Number 3, 5.5y equals 70. I should have done some examples that were written the other way. So if it was written out this way, with the variable on the right-hand side, we're still going to divide by the 5.5. I just kind of changed that one a little bit. And when we do this division here, 70 divided by 5.5 is 12.727. And the 7.2 actually repeats on, so you can even put the bars over it. And that's the answer there. If you do the check there, if you do 5.5 times 12.7, or 12.72, since you rounded it, you'll be a little bit off. But when we do 12.5 times 7, 5.5 times 12.7, we get 69.85. And that's pretty close to the 70 that we were looking for. So that's okay. All right. Go ahead and try 4 and 5 on your own. Push pause, give them a try. All right, here's the steps for 4. We do need to divide by -18. That gives us the 1b that we want. And that ends up being -2. Here we'll divide by -16. And we get -9. Number 6, there's a star by it because there's an extra step you actually have to do for this one. Notice that we have like terms here. We want to combine those. This gives us 5.5c equals 11. So that was the first step that we had to do, combine like terms. And then we'll solve it just like an equation. We have times going on here, 5.5 times c, so divide by 5.5 on both sides. And we get c is equal to 2. Simple enough. All right, next part here is the multiplication property of equality. It's the same type of thing, but the key part here is non-zero number. You cannot divide by 0, so as long as you divide by anything other than 0, you're going to be good. The inverse operation of division is multiplication. So next part here, taking a look at a couple of these examples, now we have some mixed up things, and now we have, for w, it's w divided by 11 here. So this is what's really happening. It's w divided by 11. And you probably ask yourself, well, how do we get rid of dividing by 11? And the opposite of dividing by 11 is multiplying by 11. And there's a specific way I want you to show your work here. Since we have fractions, I want you to write divided or times 11 on both sides here, because that's the opposite of dividing. And keep it in the numerator there, or you could even put times 11 over 1 to keep them like fractions. When we do this, on the left-hand side we get 55. And on the right side, what we want to happen is we want it to cancel out. So when you're multiplying by 11, what happens is you actually end up getting a fraction. And since we've learned a little bit about fractions in Unit 1 and 2, we know that these will cancel out, leaving it with just w. To check it, we can write our original equation. And instead of w, we're going to take that w out and put a 55 there. So 55 divided by 11 actually is 5. On number 2, we are dividing by 6 on the right-hand side here. Remember, we're trying to isolate c. So the opposite of dividing 6 is multiplying by 6. And you can think about it as 6 over 1 if you want to. The 6's cancel out, leaving you with just c on the right-hand side. And we get negative 54. To speed through a couple of these here so you have a quicker video, I'm going to skip the check on this one to writing it out. But all you need to do is think in your head, if you put negative 54 in there, divided by 6, does it give you a negative 9? And it actually does. Number 3. What we have to do here is we're dividing by 3, so we're going to multiply by 3 on both sides. And we get 19 times 3, 57. And if you need to stop and re-watch a couple of these, or if you need another explanation, please let me know, or just push pause and rewind it there. Number 4, we have dividing by negative 8. So you can kind of think about it as this way. The opposite of dividing by negative 8 is multiplying by negative 8. So we are going to take this equation here, multiply by negative 8 on both sides. So what happens is this negative 8 and negative 8 cancel out. And remember your multiplication rules. A negative divided by a negative is a positive. And that's what we want. So those cancel out, and we get positive 24. This is a good one to actually check, though, just to make sure our signs are right. If we put 24 in for this j, 24 divided by negative 8, we want to see if it's equal to negative 3. And in that case, if you type that out, you do get the right signs there. Number 5, here's what we need to do for number 5. We have k divided by negative 2. So the opposite of dividing by negative 2 is multiplying by negative 2. When you do the math there, you get negative 26.5. Number 6. Same type of thing here. We're going to multiply by negative 20.18. So these can actually work out with fractions as well. And what we end up getting, if we get 148.323 is equal to c. That'd be a good one to check there. Go ahead and get your answer divided by negative 20.18. Make sure it works out. And it actually does. So that's something you can actually do on your calculator as well. Last one here, okay? For these equations, what you want to do is try to cancel things out. All right, so these equations here are basically what we want to do is try to balance them out. So this is kind of taking out the numbers and seeing if you can apply it to different shapes. So on the left side, we have 2 triangles and 6 rectangles, or what are those called? Squares. So what we want to do is try to group things like we've seen in the past. What we want to do is try to figure out how many squares are equal to 2 triangles. So this is really like 2 x's is equal to 6. There's 2 triangles and 6 squares. Okay, so you could solve that equation by dividing, and what we would do is divide by 2, and what we get is x equals 3. But how will we do that with the pictures? Basically, what we want to do is figure out how many of these triangles, if we have 2 groups of triangles, how can we figure out how many squares there are? So if we group these together like this, we would have 1 triangle is equal to 3 squares. Okay, so for this last one here, we have basically 3 rectangles on the left side, and if you count all these up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 individual ones on the right side. So we basically need to put these guys on the right side into 3 equal groups. So if we figure out how to divide those into 3 equal groups, this is basically like the equation 3x's equals 12. And you'll find out that when we divide by 3, you actually get 4. And if I show you how to get these into 3 equal groups, each one would have 4 in it. So there's 1 equal group, 2 equal groups, 3 equal groups. Thanks for watching, guys. I'm going to have my advisory say hello to you.
Hi!
Okay. See you guys tomorrow.